Hey there, Math Club. This is Noah with a Math Club video bonus. In our last episode, Gleaming the Cube, Pete explained that the Rubik's Cube is symmetrical, and that without the colored stickers on each cubie's faces, it would be impossible to even tell which parts of the cube had been rotated. To make this a bit simpler, he asked us to envision a two-dimensional square in place of the cube. We thought it might be easier to understand this explanation with a video bonus.
So if you were to think about a square, what might be some of the symmetries you could identify with a square?
Well, first, let me make sure I'm picturing this right. Can I picture this as if I have a piece of paper that's cut out in the shape of a square and it's just sitting there on the table in front of me? And you're asking me what are some different ways that I could move that square that would be symmetrical moves where the square would look like it was in the same configuration after I moved it than it was before?
Exactly. In fact, I would like you to think of everything you can do to a square that would leave its appearance unchanged.
Well, I could only think of two things that I can do to a square that would meet that definition. One would be I could reach down and just rotate that square either 90 degrees or 180 degrees, or I could pick the square up and flip it over and put it back down so the other side of the square is now face up. So I think those are the only two things I could do where after I made the move, it would still look like the same square I started with.
Yeah, rotations and a flip. And if you allow yourself to combine some arbitrary number of each, rotate, flip, rotate backwards, flip again, whatever you come up with, you will have described all of the possible symmetries of this square. Now, we have deliberately said, how can you move the square so that we cannot tell that something has happened to it? Now we actually do need to tell what's happening so that we can quantify what's going on.
So we need some sort of equivalent to what the colored stickers on the Rubik's Cube would provide. So that when you rotate a face, even though the cube itself looks like the same 3x3x3 cube, the colored stickers indicate that you've made a rotation.
Yeah, exactly that. Now, instead of using colors, what about numbers? Let's write some numbers down on our square. There are four corners, so I will propose writing 1, 2, 3, 4 in that order, going around the square in the clockwise direction. In the upper left corner, I will write 1. In the upper right corner, I will write 2. In the lower right corner, I will write 3. And in the lower left corner, I'll put a 4. So now I've got 1, 2, 3, 4. And since we need to flip the square sometimes, I will flip the square over and write the numbers 1, 2, 3, 4 so that they correspond to the same ordering that they had on the original sides.
So the one corner is going to be the one corner regardless of which side you're looking at.
Yep, that's the idea. Now, when we put that square down and move it, we can see that the numbers have changed position relative to the home base position of 1 in the upper left, 2 in the upper right, 3 in the lower right, 4 in the lower left.
Oh, I see what we're doing. This is just like you said, it just took me a minute to get there. This is a simplified version of what we can do with the Rubik's Cube and all the different ways we can twist and turn it around.
Exactly.
And there you have it, Math Club. We hope this video has made it a little easier to picture how we can catalog and quantify the different ways we can rotate faces of the Rubik's Cube while maintaining its original symmetry. This has been Noah with your Math Club video bonus, and we'll see you next time.